In this video, we're going to solve absolute value inequalities. Now, the ones we're going to solve in this video are going to be relatively simple, but in the next video, we'll go through some more advanced ones. But simple or advanced, the general approach is exactly the same. So not only is it exactly the same from simple to advanced absolute value inequalities, but it's also the exact same mechanics as what we do to solve any kind of absolute value equation. The same like general mechanics, except instead of solving different equations along different intervals, we're solving different inequalities. So, okay, we start off by simplifying the inequality as much as possible using just the properties of inequality, adding, subtracting to both sides, multiplying and dividing things by both sides. But if you do that with a negative, multiply or divide with a negative number, you have to flip the inequality. So if we add 2 to both sides, 16 plus 2 is 18. Divide both sides by 3, and we get the absolute value of 4 minus x is less than 6. We don't have to flip the inequality. 3 is positive. Now we can't go any further. And so now it's just like absolute value equations. We go to every single absolute value in the entire inequality here, and then mark off the boundary points. Okay, so there's just one boundary point here, that's 4. But if there was a quadratic inside here or any kind of polynomial, whatever, and there was multiple points where, since we're dealing with polynomials, we just have to find where they equal 0. That's where they're going to cross or switch from positive to negative. Then we would get all of those different points where the different x values that make the expression 0, and then mark off all those points for all the different absolute values. But here, these problems we're doing here are simple, so there's just one point. So now we need to analyze these two regions here. Let's start with x being less than or equal to 4. In that case, this is going to be 4 minus x is going to be positive or 0. So we just remove the absolute value, and now we solve the inequality in this case. With absolute value equations, we'd solve the resulting equation. Here we solve the resulting inequality. Now, since we're dealing with these simple inequalities, we're just left for all these problems, we're just left with a simple linear inequality where we don't even have to, we can just solve this like a regular, like it's just using the properties of equality. So subtract 4 from both sides, multiply both sides by -1, flip, and we're done. But for more complicated cases, we might have a full inequality here that we have to, maybe it's a quadratic inequality or whatever, and we have to bring everything to one side and solve it like we would a more complicated inequality. And it might take time, but that's the whole process. We would fully solve it, get the solution. But just like we did with absolute value equations, we need to compare this to the interval we're in. And what we're doing here is we want to take the and between these two. It's where we want to note where they cross. So where does x being less than or equal to 4 cross with x being greater than -2? Well, that's going to be, I can note that right over here. So that's going to be when x is greater than -2, less than or equal to 4. And now those are solutions to the original inequality. Any of these x values are solutions to the original inequality. Okay, but now we need to do x is greater than 4. That would make, in that case, this is 4 minus x is always negative, so we remove the absolute value and put a negative sign out front. Now let's solve this. So -4 plus x is less than 6. Add 4 to both sides. X is less than 10. So where do these cross over? Let's see. That would be x is less than 10. X is greater than 4. Okay. Now, so all we need to do now is the final answer is going to be, we know that all of these are the answers. So really it's this or this are the answers. Well, now we just need to apply an or compound inequality to these two. Maybe we can condense this down. So if we're going from, let's see, -2 to 10, and then we're 4 is in the middle. So we've got x is greater than 2, less than or equal to 4, less than or greater than 4, less than 10. So we can see it's the or between these two is going to be this. From -2 to anything from -2 to 10. So not including the endpoints. And that's the final answer. You plug in any value between -2 and 10 to this inequality, that will satisfy it. Okay, let's add 4 to both sides. We want to start by simplifying as much as possible. Divide both sides by 2. 2 is positive, so we don't need to flip anything. Okay, we got one boundary point at x is equal to -3. So let's do x is greater than or equal to -3. X plus 3 is going to be positive or 0. So x is 5 minus 3 is 2. So, but now where do these two cross over? So we've got, let's see. -3, 2. X is greater than or equal to -3. And x is greater than or equal to 2. So the cross is going to be x is greater than or equal to 2. Okay, now what about when x is less than -3? This is always negative. So we've got subtract 3 from both sides. Multiply both sides by -1. Flip the inequality. X is less than or equal to -2. Where's that cross with x is less than -3? That's just going to be x is less than -3. So now just an or between these two is going to be the final answer. So x is greater than or equal to 2, or x is less than -3. Well, that's it. We just leave it like it is. We can't simplify this anymore. That's the final answer. In interval notation, this is going to be minus infinity to -3 in union with 2 to infinity. And actually, I made a mistake here. I forgot to distribute this minus here. So we would have, and then adding 3 to both sides, we would get 5 plus 3 is 8. Okay, and then multiplying both sides by -1, this will become -8. And now these cross over here. X is less than -3 and x is less than or equal to -8 crosses over to where we just have x is less. The and criteria between those two is that x is less than or equal to -8, right? And x is less than -3 and x is less than or equal to -8 would be just x is less than or equal to -8. And now applying the or between these two, you get, this just becomes -8. This becomes -8. Okay, let's subtract 6 from both sides. Now here, we want to be on the lookout for special case solutions, because we know that this, when, the absolute value of 4w minus 5, no matter what w you plug in any real number, we're just thinking about real numbers, that's going to be greater than or equal to 0, no matter what. So there's no solution here. No solution. There's nothing that's going to result here that's going to be less than or equal to -4. Now, for more similar to absolute value equations, or just like absolute value equations, for more complicated absolute value inequalities, maybe you won't be able to see this. When there's no solution, it won't be so explicit. But, I mean, that's fine. Then just solve it like you normally would. So we would just do what would happen is we would go through this whole process, the 4/5, and go through solve the two separate inequalities, and there'd be no solution to any of them. And so you'd write no solution. Okay, let's see. Let's subtract 13 from both sides. Minus 6 minus 13 is minus 7. Okay, we see this negative number on the one side and an absolute value on the other side. That should signal special case solution because, okay, this is never going to be anything less than 0, ever. But this is less than 0. So does that mean there's no solution? Well, no, because it depends on what the inequality is. This says greater than. Well, yeah, this will always be greater than -7, no matter what, because it's going to be greater than or equal to 0 no matter what. So P can be any real number. Now, again, same idea. If it was, you had some complicated absolute value inequality and you couldn't see that the solution was still all real numbers, but you couldn't see it, just solve it like normal. If we went solve this like normal, we'd solve two separate inequalities and realize, okay, the solution is any number on the entire number line. Okay, let's get the variables on the left side. Okay. All right, now let's subtract 5 from both sides. Minus 11 minus 5 is minus 16. Now let's multiply this entire inequality by minus 1. So we're going to need to flip the inequality symbol. Okay. So when does 2p plus 4 equal 0? That's when p is minus 2. Okay, so that's just one boundary point here. Let's start with p being greater than or equal to minus 2. In that case, 2p plus 4 will always be positive or 0. So we can just remove that. Okay, let's subtract 4 from both sides. Now let's divide both sides by 2. So P is less than or equal to 6. Where do these overlap? P is greater than or equal to minus 2, but less than or equal to minus 6. So that's going to be P is less than or equal to 6, greater than or equal to minus 2. Okay, now what about when P is less than minus 2 in this region? In that case, 2p plus 4 is always negative, so we do minus 2p minus 4, so minus 2p, okay, divide both sides by minus 2, flip the inequality, p is greater than or equal to minus 10. All right, so where do these two overlap? P is less than minus 2, but greater than or equal to minus 10. So let's see. Minus 2, minus 10. Less than minus 2, but greater than or equal to minus 10. So it's between minus 10 and 2, including 10, not including minus 10, not including minus 2. So between like that. So now what's the or between these two? So we've got, let's see, 6 minus 10, 2, 0. So, okay, minus 10, or no, put minus 2, yeah. Then all the way to 2, then minus 2 all the way to 6, including 6. So it's just between minus 10 and 6, including the endpoints. That's it. So we can do this. Oh, minus 10. Okay, let's go ahead and flip this. Okay, let's subtract 2 from both sides. Okay, so where does minus 5c minus 4 equal 0 when c is minus 4/5? So, okay, minus 4/5. Okay. Let's see. So when c is equal to, when c is less than or equal to minus 4/5, c is less than or equal to minus 4/5, minus 5c minus 4 is going to be positive or 0. So we just remove the absolute value. Minus 5c is greater than 12. Divide both sides by minus 5. C is greater than, no, c is less than minus 12/5. Flip the inequality. Okay, where do these cross? Here. So c is less than minus 12/5, and then less than or equal to minus 4/5. That's going to be c is less than minus 12/5. Okay, now what about when c is greater than minus 4/5? In that case, this will always be negative. So we do, okay, 5c plus 4 is greater than 8. 5c is greater than 4. C is greater than 4/5. So where do these cross? C is greater than 4/5. C is greater than minus 4/5. That's going to cross where C is greater than 4/5. So now what is the or between these two? C is less than minus 12/5, or C is greater than 4/5. That's it. We can't, this is as simplified as we can write it. So C is less than minus 12/5, or C is greater than 4/5. In interval notation, you could do in union with, like that. Okay. We can't simplify this any further. So what's the crossover point for y plus 3 over 6? Well, this is still polynomial, right? This is 1/6 y plus 3. So we just need to find out where this equals 0. So, okay, cross multiplying, we get y plus 3 is equal to 0. So y is equal to minus 3. So that's the crossover point is that y is equal to minus 3. Okay, so when y is greater than or equal to minus 3, this is going to be positive or 0. So we do, okay, multiplying this entire inequality by 6, we get y plus 3 is less than 12. Subtracting both sides by 3, y is less than 9. So where do these cross? Y is greater than or equal to minus 3, or y is less than 9. That's just going to be this. Okay, now what about y is less than minus 3? In that case, this will always be negative. So we do is less than 2. So we can do this. Multiply both sides by minus 1 and flip the inequality. So multiplying both sides by 6, we've got now subtracting 3 from both sides. Okay, y is greater than minus 15. Where do these two cross? Y is less than minus 3. Y is greater than minus 15. That's going to be here. So now we just need an or between these two. Well, we can see it's going to be, we could do this. Y is less than 9 and greater than minus 15. That is the solution.